Alright, so let's do an example. So let's consider a 2 by 2 matrix. So suppose x1 prime is 4x1 plus 2x2. x2 prime is 3x1 minus x2. This can be rewritten as x the vector prime equals to the matrix 4, 2, 3, negative 1 times the vector x. So based on the theorem in the previous video, all we need to do is to diagonalize this matrix. So if you want to diagonalize the matrix, we first solve the characteristic equation. So determinant of a minus lambda equal to 0, lambda I equals 0. So 4 minus lambda 2, 3, negative 1 minus lambda equal to 0. 4 minus lambda, negative 1 minus lambda, minus 2 times 3 equal to 0. So lambda squared minus 3 lambda plus minus 4 minus 4 minus 6 equal to 0. Lambda squared minus 3 lambda minus 10 equal to 0. So lambda minus 5 and lambda plus 2 equal to 0. So lambda is negative 2 and 5. So there are two eigenvalues. So after solving that, we need to solve for eigenvectors. So for lambda 1, which is equal to negative 2, we solve a plus 2i times v equal to 0 vector. So we solve 6, 2, 3, 1 times v equal to 0. So we can always choose vectors with integer entries. So to make that equal to 0, v can be 1, negative 3. That will be the quickest choice. So there are many choices. So other choices, you can choose negative 1, 3, that's fine. 2, negative 6 is fine. As long as it's a multiple of that. Any choices are equivalent. So we usually just choose the most convenient one. So that's our v1. And for lambda 2, which is 5, we solve a minus 5i, 5i times v equal to 0. So that's negative 1, 2, 3, negative 6 times v equal to 0. So we choose v2 to be 2, 1. It's the most convenient choice. Again, there are many other choices, but that's the most convenient choice. So that's it. So the general solution is of the form that x is equal to c1 e to the lambda 1t times v1 plus c2 e to the lambda 2t times v2. So it's equal to c1 times e to the negative 2t times 1 negative 3 plus c2 times e to the 5t times 2, 1. So that's one way to write it. If you want to write it in the not a vector form, then you can write it as x1 equals to the c1 e to the negative 2t plus 2c2 e to the 5t. And x2 is negative 3 c1 e to the negative 2t plus c2 e to the 5t. So that's our general solution. Alright, so let's do a modeling with tanks again. So 3 tanks. 3 brine tanks. So tanks with water and salt in it, basically. Brine tanks. So let's have first tank being 20 gallon. Second tank being 40 gallon. And third tank, I need to make this bigger, 50 gallon. Okay, so pipes are going all over the places. The fresh water is coming in at a rate of 10 gallon per minute. And the mixed liquid from first tank is going into the second tank at the rate of 10 gallon per minute. And the mixed liquid in the second tank is going to the third tank at the rate of 10 gallon per minute. And mixed liquid in the third tank is getting drained at the rate of 10 gallon per minute. So notice that every single tank has 10 gallon per minute coming in and 10 gallons per minute leaving the tank. So the volume of water in each tank remains constant, 20, 40, 50. It's not decreasing or increasing. All right, so let's assume the amount of salt is x1 pound of salt in the first tank, and x2 pounds of salt in the second tank, and x3 pounds of salt in the third tank. And let's assume the initial conditions are only the first tank has 15 pounds of salt, the second tank and the third tank, which is water. Okay, so let's first list the differential equations. So the left-hand side is going to be the change of amount of salt in each tank. Okay, so let's see what happens. For x1, water is coming in, so technically the amount of salt coming in is 0 times 10 gallons per minute. Don't even know why I'm writing it down because it doesn't really contribute to anything. And the amount of salt leaving is minus 10 gallons per minute. And the concentration multiplied by the concentration of salt in the first tank, which is x over 20 gallon pound per gallon. So that's tank 1. Tank 2, the amount coming in is the amount leaving the amount of salt coming into the second tank is literally the same as the amount of salt leaving the first tank. So it's 10 gallons per minute times x1 over 20 pound per gallon. And the amount leaving is 10 gallons per minute times x2 over 40 pound per gallon. So that's x2. For x3, similar. The amount of salt coming in to tank 3 is the same as the amount of salt leaving tank 2. And the amount of salt leaving tank 3 is 10 gallons per minute times x3 over 50 pound per gallon. So if we simplify everything, we get x1 prime is equal to negative 0.5 x1, and x2 prime is 0.5 x1 minus 0.25 x2, and x3 prime is it's nothing in the first term. It's 0.25 x2 minus 0.2 x3. Alright, so let's move down a little bit. Let's see so we can still see it. So this tells us that the vector x1 prime, x2 prime, x3 prime equals to the matrix negative 0.5, 0, 0, 0.5, negative 0.25, 0, 0, 0.25, negative 0.2 times x1, x2, x3. So all we need to do is to investigate this matrix. A. Investigate means to diagonalize it to solve this differential equation. So here's a trick here. So you notice that A is in lower triangular matrix. So this trick works for lower triangular matrices, upper triangular matrices, or diagonal matrices. So for a lower triangular matrix, the eigenvalues are just the entries on the diagonal. So the 3 entries on the diagonals are precisely eigenvalues. So eigenvalues are negative 0.5, negative 0.25, and negative 0.2 are the 3 eigenvalues. It's not essential to show you how to solve the eigenvectors because you all know how to do row operations. So I'm just going to tell you what the eigenvectors are without actually demonstrating how to solve them because you have already seen too much row operations. So for the eigenvalue negative 0.5, the corresponding eigenvector is 3, negative 6, 5. And for the eigenvalue negative 0.25, the corresponding eigenvector is 0, 1, negative 5. And for the eigenvalue negative 0.2, the associated eigenvector is 0, 0, 1. So the general solution is x of the form c1 e to the lambda 1t times v1 plus C2 e to the lambda 2t times V2 plus C3 e to the lambda 3t times V3. In particular, you can write it in terms of the individual functions x1, x2, and x3. So x1 is C1 e to the lambda 1t, which is negative 0.5t, times the first entry of V1, which is 3, and plus C2 times e to the lambda 2t times the first entry of V2, which is 0, and C3 times e to the lambda 3t times the first entry of V3, which is also 0. Okay, same thing for the other two. So x2t is negative 6 C1 e to the negative 0.5t plus 1 times C2 e to the negative 0.25 t plus 0. And x3 is 5 times C1 e to the negative 5t, not 5, 0.5, plus, minus 5 C2 e to the negative 0.25t plus 1 times C3 e to the negative 2.2t. Okay, so this is the general solution, but remember we have an initial condition, so we can solve for particular solution. I am going to move down a little bit. We just copy down the initial conditions. So x1 of 0 is 15, x2 of 0 is 0, x3 of 0 is 0. So I can move down here. Okay, so we're going to move down to the left here. So we get 15 is equal to 3c1 and 0 equal to negative 6c1 plus c2 and 0 equal to 5c1 minus 5c2 plus c3. This is a lower triangular matrix. It's really easy to solve. Don't really need to do any row operations. The first row tells you that C1 is 5, and the second row tells you C2 is 61, which is 30. And the third row tells you that C3 is 5C2 minus 5C1, which is 150 minus 25 is 125. So the particular solution is x1 is 3c1 times 3c1 is 15, negative 0.5t. x2 is negative 6c1, that's negative 30, e to the negative 0.5t, plus c2, which is 30, e to the negative 2.5t. And x3 is 5c1, that's 25, e to the negative 0.5t, minus 150, e to the negative 0.5t, plus 125, e to the negative 0.2t. Okay, so that's our particular solution. So just one last thing we can make as an observation. So as t goes to infinity, notice that all the exponents have negative 0.5t or negative 0.5t or negative 0.2t. That means they all go to 0. So as t goes to infinity, x1t, x2t, x3t all go to 0. And this is expected because, remember, the system looks like this. And water keeps coming in, and the mixed liquid keeps leaving the tank. So eventually, all three tanks gets fully diluted. Right.